Hello, my name is Ryan Sloan, and today I'm going to be talking about non-traditional foundations and how they relate to construction. Foundations are one of the most important parts of any construction project because everything built above them depends on them for support. Most people are familiar with traditional foundations, but those systems do not work for every project. Depending on the soil, size of the structure, groundwater, and other site conditions, contractors may need to use more specialized foundation systems. I'm going to cover a few of those systems and explain how they affect the construction process. The main purpose of a foundation is to support the structure and transfer its load safely to the ground. Foundations can generally be separated into shallow and deep foundations. Shallow foundations are normally used when the soil is close to the surface and is strong enough to support the structure. They're usually simpler, cheaper, and faster to install. However, shallow foundations are not always an option. The soil near the surface is weak, there's high groundwater, or the building has extremely heavy loads. A deeper, more specialized foundation may be necessary. One common type of foundation is a pile foundation. Piles are long structural elements that extend deep into the ground. Instead of relying on weak soil near the surface, they transfer the building's load into stronger soil or rock deeper underground. There are two main ways piles can transfer load. End-bearing piles, which extend down until they reach a strong layer that can support the structure, or friction piles, which use resistance between the slides and the pile they are surrounding to support the load. There are also several installation methods that can be used when driving piles into the ground. Holes can be bored and filled with concrete, or other methods such as continuous flight auger piling can be used. These methods depend on the soil conditions, structural requirements, and characteristics of the job site. There are several other foundation systems that can be used when traditional foundations are not practical. Drilled shafts and caissons are created by drilling into the ground and constructing the foundation within the drilled hole. One advantage is that they can create less vibration than driven piles, which can be important when working near existing buildings. Another option is a helical pier. These are installed by essentially screwing them into the ground until they reach soil that can be used to provide enough support. They can be useful in areas where the soil is unstable or expansive. Mat foundations work a little bit differently. Instead of going deep, a mat foundation focuses on spreading the load across a large surface area. This can reduce stress on weaker soil and help reduce differential settlement. From a construction management standpoint, the foundation system affects much more than just a structural design. Deep foundations can require specialized equipment such as drilling rigs or pile driving equipment. The project team has to make sure that they can access the equipment on site and that the foundation work is properly coordinated with other activities. Soil conditions, groundwater, weather, material deliveries, inspections, and subcontractor schedules all have to be considered. Foundation work also happens very early in a project. If there is a major problem or delay during this phase, it can affect everything that follows. That makes it planning geotechnical information extremely important. Foundation construction is also changing the construction industry. Looks for ways to become more efficient and reduce environmental impacts. Some examples include recycled steel, piling systems, lower carbon concrete, mixtures, precast piles, and prefab foundation components. In conclusion, there's no single foundation system that works for every project. Non-traditional systems provide solutions when conventional systems can't. Choosing the right system early improves constructability, cost control, scheduling, long-term performance, and project safety. Thank you.